Hi Lamai, so here we are to talk about the question patterns that you get in limits, right? First thing, now you observe you have a question like this. Let's say you have limits of x squared minus 4 over x minus 2. This is the question you have, and it is when x tends to 2. When x tends to 2. Right now, if I ask you, now I told you that in the last video, I told you that when it is a linear equation, we can go for a direct substitution, right? But still, we can go for direct substitution even for these kind of fancy limits of x plus 1 over x plus 5 when x tends to 2. Right, so here we can get the answer as 2 plus 1 3 and 2 plus 5 when x get closer to 2. Right, what happens to this whole thing? Numerator will get closer to 2 plus 1 3 and denominator will get closer to 2 plus 5 7. So the whole fraction will get closer to 3 over 7. Like that we can directly substitute and get. Right, so when you substitute it here, what will happen? When you substitute 2 here, numerator and denominator both you will get 0. So you know 0 over 0 is an undefined condition in mathematics. 0 over 0 is undefined in mathematics. So like that you have to avoid these problems with undefined conditions. That means you have to avoid the undefined condition and then you have to try to do the sum removing the undefined condition. So I'm going to teach you, I told you that we are going to learn the question patterns. So actually this means that we are going to learn how to remove these undefined conditions and then continue the sum. That's what we are going to learn. Clear? Right. Okay, so how can we do this one? Yes, how can we do this question? Right. So what are the undefined conditions actually? 0 over 0 is undefined. Infinity over infinity is undefined. Clear? So like that we have different undefined. 0 to the power 0 is undefined. Clear? Then infinity to the power 0 is undefined. Infinity minus infinity is undefined. Clear? So we have these kind of undefined terms in undefined conditions in mathematics. Right. So when you're finding limits, we should try to avoid these ones. Clear? Right. Now here, actually, our method number 1 is removing the common factors. You can write the method number 1, that is removing common factors. So if you have any common factor, we have to remove the common factors, right? Removing common factors. Removing common factors. Okay, how can I remove the, okay, we can factorize. X squared minus 4 we can write as x minus 2 x plus 2 over x minus 2. Limits when x tends to 2. So you can say this x minus 2 get cancelled. Now your question look like this, limits of x plus 2 when x tends to 2. So rule number 8, when it is a linear polynomial, when it is a polynomial function, we can just directly substitute and get, see, when x get closer to 2, x plus 2 get closer to what? 2 plus 2, 4. Therefore, the answer is 4. Is it clear? Right? So we will move for another example soon. Right? Okay, this one. Limits of x squared minus 3x plus 2 over x minus 2. Right? When x tends to 2. Right. See whether we can direct substitute and get the answer. So when you get a fraction, or when you get this term, check whether sometimes we can direct substitute and get the answers if you do not get any undefined conditions. See, but here see when you substitute 2, when you substitute, here we are getting 4 and here we are getting minus 6 plus 2. So numerator will become 0 and denominator also when you substitute 2 minus 2 will become 0. Therefore, we will try to factorize this and remove the common factors, right? So this is x into x, 2 into 1 minus x minus 2. Limits when x tends to 2. So these common things get cancelled. Now what you can do, now this is just limits of x minus 1 when x tends to 2. So we can direct substitute and get the answer. Clear? Substitute 2 minus 1, 1. So the answer is 1. Clear? So that is our method number 1. What is it? Removing common factors to avoid the undefined condition. Clear? Okay. And number 2. Question number 2. Question pattern number 2. Right? So that is actually questions with square roots. Okay, questions with square roots in a fraction. Right, questions with square roots, simply questions with square roots. Right, so what you had to do with there? Okay, we will move to one example question, then you can understand, right? Okay, we will do this question. Limits of x minus 2 over 2 minus root 6 minus x, then x tends to 2. We will just direct substitute and see what happens. See, 2 minus 2, 0. Numerator will become 0. How about the denominator? When you substitute 2 minus root 6 minus 2. That is, root 6 minus 2 means what? Root 4. Root 4 means 2. So, denominator also will become 0. So, 0 over 0. Okay. Right, even we can't factorize this. That method number 1 use karana. So keep in your mind what you have to do is actually when you have fractions and when you have square roots in them, what you have to do is you have to multiply both denominator and numerator. You have to multiply both denominator and numerator by what? By the conjugate of the line that you have the root. Clear? Solving problems related with roots, with square roots. What is our first step? We have to multiply both denominator and numerator by the conjugate of the line that you have the roots. Right? So this is 2 plus root 6 minus 6. 2 plus root 6 minus 6. Now Pute, keep in your mind, when you get into this step, when you multiply this denominator, now you consider this denominator and we get the reciprocal, right? No, the reciprocal, conjugate. So when you multiply these two, we are always getting what? Difference of 2 squares. So very easily we can write that part, x minus 2 over difference of 2 squares, 4 minus 6 minus 6 when x tends to 2. Clear? So 2 squared means 4. Root 6 minus is x into root 6 minus x is 6 minus x. Okay, so further we can write this as limits of x minus 2 and minus 2 plus x when x tends to 2. Okay, and then we forgot something. Keep in your mind, now we pair this one and we write this as a difference of 2 squares. At the same time, this thing we have here. But keep in your mind, we have this remaining thing. Next step, you just separate it and write as like this. From that one, Pute, without any undefined conditions, we can find the answer. Right? So this is equal to what? When x value get closer to 2, yes, 6 minus 2, that is square root of 4. Square root of 4 means 2. So 2 plus 2, this part is equal to 4. Now you can write, this is a multiplication, now you can write it here. Okay, and this one also you can see 4. Limits of x minus 2 over x minus 2, we can take, we can write it like this, right? Yeah, x minus 2 over x minus 2 when x tends to 2. So these two things get cancelled. Here it is 1. So limits of 1 when x tends to 2 is always 1. Right? Therefore, 4 times 1. The answer is 4. Clear? Right. So that is method number 2 that we have to follow to remove the undefined condition. Number 3. Number 3. When the limits, you can write when limits tends to infinity. When limits tends to infinity. Right? Okay. Sorry, I wanted to highlight. Okay. When limits tends to infinity. So what do you think? Right? For example, this one. Limits of x squared plus x plus 1 over x plus 1 when x tends to infinity. Okay. So can you see when you substitute infinity, here numerator and denominator both becomes infinity. So infinity over infinity is not defined. So we can't go with that method. So what we have to do in these kind of questions is this, Pute. I will divide both denominator and numerator of this fraction by the highest power. Right? What I am going to do in these type of questions, we will divide both denominator and numerator, right, by the term with the highest power. So we have x squared. So I will divide all the terms by x squared. Right? So here we are getting 1 plus 1 over x plus 1 over x squared. And denominator, when you divide by x squared, we are getting 1 over x plus 1 over x squared. Okay, that is limits when x tends to infinity. So right, so what happens here when x tends to infinity? The denominator 1 over x, it is also 0. This one also tends to 0. All the things tends to 0 when x tends to infinity. So this is 0, this becomes 0, 1 over, this is 0, that is 1 over 0, this tends to infinity. Clear? Right. So method number 4, method number 5 from the next video. Goodbye. So in this case, what we have to know is 1 over, if it is 1 over, when the denominator tends to 0, the answer tends to infinity, and when the denominator tends to infinity, your answer from this overall fraction tends to 0. So you should know this fact, then you can do these questions, right? Let's try another example, one more, right? Say limits of x to the power 3 plus 1 over x to the power 3 minus 2x plus 1 when x tends to infinity. Okay, so what I'm going to do is I'm going to divide all the terms by the highest power that you can see is x to the power 3. So I'm going to divide both denominator and numerator by x to the power 3. When you divide the first term by x to the power 3, that is 1. 1 divided by x to the power 3, 1 over x to the power 3. X to the power 3 divided by x to the power 3, 1. Minus 2 over 2x divided by x to the power 3 minus 2 over x squared. And 1 divided by x to the power 3 plus 1 over x to the power 3. Limits of x tends to infinity. Okay, so you know when the denominator, when the denominator tends to infinity, the answer tends to 0. So this becomes 0, all these 3 tends to 0. Therefore your answer will be plus 1. Okay, right. Now let's move to the fourth question pattern that you could get. That is, right, if limits of x to the power n, if you have to find the limits of x to the power n minus a to the power n over x minus a when x tends to a, right? So these are very important, Lamai. This should be n, here n, and okay, this is a, x to the power n minus a to the power n over x minus a when x tends to a. You should get this format exactly then you can write the answer directly as, right, you can write the answer directly as na to the power n minus 1. This is actually a shortcut method that you can get the answer where n is a rational number. In this case, n is a rational number, right? So we will do an example and see. Now you know that x to the power 2 minus 4 to the power 2, right, over x minus 4. Right? When x tends to 4, see, all these terms are the same. You can see 4 x squared minus 4 squared, x minus 4, x tends to 4. We have this way, let's say. Right now, you know, to do this using the factorizing method, I told you if you have common factors, we can remove them and remove the, remove the undefined condition. Right? Now, this one, if you do like that, you will get like this. X minus difference of 2 squares, x minus 4x plus 4 over x minus 4 limits when x tends to 4. X minus 4, x minus 4 get cancels, and we can just have limits of x plus 4, x tends to 4. We can directly substitute 4 and get the answer as 8. So however, from this question you should get the answer as 8. Now you see, with this shortcut method, right, with this definition that I told you, using this one, right, we can get the answer directly. You have to identify that this is the format. The mega format take your theorem gatara passe. What is the answer? Yes, what is n? What is n? 2, right? What is a? 4. So it is n a to the power n minus 1. So the answer will be 2 4 to the power 2 minus 1, which is equal to 2 times 4, 8. Clear? So very easily we can get the answer. So however, this value and this value should be same thing, and x minus 4 x squared minus 4 squared over x minus 4 when x tends to 4. That is the way that it should stay. Another example, limits of x to the power 3 minus 5 to the power 3 over x minus what? X minus 5 when x tends to 5. If so, if this is the format, if this is the format, you just understand, try to understand the pattern, right? Then your answer will be what? 3 times 5 to the power 3 minus 1. Okay, so 3 times 5 squared, 75. This will be the answer. Right? Okay, so that is the number 4. And number 5. Right? So this one also I will directly teach you, but there is a proof. We have to state some theorem called, not to prove, we have to state some theorem called sandwich theorem, and from that we can derive this, right? So if you get limits of sine x over x when x tends to 0, limits of sine x over x when x tends to 0, okay, there also you should understand this. Now when you go for a direct substitution, you can say numerator we are getting sine 0, denominator we are getting 0, so 0 over 0 means it is an undefined condition. Now it is undefined, right? Now what you have to do, now you understand the format here. See, sine x over x when x tends to 0. If it is the way that you have, then your answer will be definitely 1. Your answer is equal to 1. Okay, we can prove this geometrically. We prove it, and also using the sandwich theorem, right? Okay, right, from this video I'm not going to teach you that part, the proof of this. You can, I'm just going to state this, and I will teach you some examples that we can directly use this. See, limits of sine a, okay, limits of sine, let's say 2x over, what should be the 2x, clear? When 2x tends to 0, when 2x tends to 0, then you can get the answer as plus 1. That is the idea. Can you understand? So this this one, they should be same, and it should also, this value should tend to 0, not to any other value. 2x tends to 0. Okay, right. Now if you have given, if they have given a question like this, let's say you have to find the limits of sine 4x over 5 when x tends to 0. This is the given question. Right. Now we can't change the angle. That means the sine value of 4x, we can't change the angle. But still, then format x. If here also x, here also you should have x. So when you think about that, now you should get here 4x. Numerator also we have to get a 4x. I'm sorry. So numerator also you have to get 4x. Denominator also you have to get 4x. And here also you should get 4x. Clear? If you want to use this. I'm going to try to get the formats now. See, limits of sine 4x. First thing, we can't change it. We have to change others according to this. Right? I will just write down, can take, this is a constant, so I can take it out of the limit sign like this. And now you have x when x tends to 0. To apply our rule, here it is 4x, numerator also it should be 4x, so I will put 4x here and I will remove that 4, putting 4 here. And also you know that when x tends to 0, definitely 4x also tends to 0. When x values get closer to 0, what happens to the value of 4x? 4x also get closer to 0. Now can you observe, we have got the format sine 4x over 4x when 4x tends to 0. Therefore this whole part is equal to 1 and the answer is 4 over 5. Okay. Right. Another example. Limits of sine squared x over 2x squared. Okay. When x tends to 0. Okay. First thing, when you have constants, we can take them out. Here we have a 2. I will take it out as 1 over 2. Limits of sine squared x over x squared when x tends to 0. Can you remember I told you a rule that when you have this whole thing squared here, we can just write it like this: 1 over 2. Let me limit take it squared sine x over x. This one we have to write without the square. X tends to 0. This whole limit we can make it squared if this term is a squared term, if the whole term is a squared term. Now we know that this part is equal to 1. Therefore, the answer is half into 1 squared half.